Yes, am I audible to you all?
Yes, sir, you are audible.
Am I audible to you all? Yes, can anyone respond?
You are audible.
Why can't I hear you? I am not able to hear you. Now am I audible to you all? Anyone who can respond?
Yes, sir.
Okay, so in the last class, we had studied about the concept of optimal caching. Okay. And today we are going to study another greedy topic which can be solved using the greedy algorithms, and that is known as data compression and variable length codes. Okay. Just a second, let me just share this screen. Yes, is the presentation visible to you?
Yes, sir.
Yes. So today we are going to study about the Huffman codes and what is the meaning of data compression. Okay. So before we can start, we need to understand the background of this problem statement. Okay. So like all other problems, this is also a greedy problem that we are going to solve. But before we can solve it, let us understand what is the meaning of data. Yes, data is any information which we want to transmit or we want to communicate, whatever. Yes. What is the general format of data for every computer, or if it is a digital device, it can only understand zeros and ones. Okay. These are the two things that a computer can understand. Or in other words, it can be called as the high voltage and the low voltage, where 1 represents the high voltage and 0 represents the low voltage. Okay. So everything that we represent must be represented in the form of zeros and 1. Okay. So yes, what is a bit? Bit now is a binary digit. Yes, it can have two basic forms. Either it can be 0 or it can be 1. So any data is to be represented in a computer must be represented in the form of binary digits, or it is also known as bits. Okay. Yes, that is what this long paragraph is saying. Sequences consisting only of symbols, zeros and ones. So this is how a computer is going to understand. If you are writing 5, then it can understand it as 1, 0, 1. Okay. If you are writing whatever, you're writing 7, so for that example, you're writing 15, this will be 1, 1, 1, 1. Okay. So on and so forth. So all the symbols must be represented in the form of binary digits. Okay. The simplest way to do this, to do what? to represent a symbol as a binary code word. Yes, to do this, the simplest way is to use a fixed number of bits. Okay, so every symbol will get a fixed number of bits. Suppose I have 3 symbols. Minimum how many bits are required? The 3 different symbols are A, B and C. Suppose there are only 3 symbols in the English alphabet instead of the 26 symbols. Okay, so now for these 3 symbols, minimum how many bits are required? If I take 1 bit, is it possible? Yes, anyone? If I take 1 bit, is it possible to represent 3 symbols?
No, sir.
Why no? Because if I represent this as 0, 1 bit means either it can be 0 or it can be 1. Okay. So if it is 0, then I will represent 1 character only. If it is 1, then another character can be represented. So at most, our 0 and 1 can represent only 2 characters. Okay. But it cannot represent 3 characters. We have 1 more character, but for that, we do not have a symbol because we have taken only 1 bit code word. Now, let us reimagine this situation where we have 3 symbols A, B, C. Okay. And for each symbol, we are going to now use 2-bit code words. Yes, if I have 2-bit code words, how many different code words are possible? It can be 00, 01, 10 and 11. So 4 different code words are possible. Okay, so I can write A as 00, B as 01, C as 10. I still have 1 code word that is unused. But then using 2-bit code words, now I can represent all the 3 symbols using distinct code words. Okay, so yes, this is the concept of fixed length codes. Okay, and the fixed length code says that to represent the number of bits, you need to apply the formula 2 to the power b. Okay, if you apply the formula 2 to the power b is less than or equal to the number of symbols, then you will get the answer. Okay, let us apply it to this case. Now the number of symbols are 3. It should be less than, it should be greater than equal to 2 to the power b. It should be greater than equal to number of symbols. Okay, now if I apply the formula number of symbols is equal to 3, okay, and I have to find some value of b which will give me 2 to the power b equal to or greater than 3. So what is such value? Such a value is 2 to the power 2. Only then I can get 4 values which is greater than or equal to 3. Okay, now if I have 32 symbols, how many bits are required? If I have 32 symbols, how many bits are required?
5 bits.
Yes, 5 bits will be required. Now if I have 33 symbols, can we do it with 5 bits?
No, sir.
No. Why? 2 to the power 5 is equal to 32. And I have 33 symbols. Okay. So at least I need 6-bit code words. Okay. So this is the concept of fixed length code. Let me go to the slide, then you can understand better. Now, the process of coding the symbols into code words is known as encoding. Okay, so the process of coding the symbols into corresponding code words is known as encoding. Okay, and encoding can be of two types. Okay, either in your network security and your network design classes, you will study more about encoding. Okay, Manchester encoding, NRZ encoding, all those encodings you will study. Okay, but for now, you need to understand there are two types of codes: fixed length codes and variable length codes. Okay, so what is a fixed length code? A code that assigns fixed length code words to each symbol. That means all these code words are of equal length. Yes, what is a fixed length code? A fixed length code says that the number of bits that are used to make code words are same for every symbol. If A is getting a 5-bit code, then B will also get a 5-bit code. Okay, C will also get a 5-bit code. Okay, so on and so forth. For all the given symbols, we will go on increasing the binary value. But here you can see all the code lengths are fixed. Okay, they are not variable. Now, let us come to the other definition, which is variable length code. A variable length code is one where the code words are of variable length. Okay, that means if A is getting a single bit code word, B can get a 2-bit code word, C can get a 4-bit code word, D can get a 5-bit code word. Okay, this is possible. Okay. The difference between a variable length code and a fixed length code is the number of code words. If you see, this row is for a fixed length code and this row, the last row, is for a variable length code. If you see in the variable length code, the code for A is single bit. The code for B, it is 3-bit. The code for C, it is 3-bit. The code for D, it is 3-bit again. The code for E changes to 4-bit. Code of F changes to 4-bit. So some of the symbols are having single bit, some of the symbols are having 3-bit, some of the symbols are having 4-bit code words. Okay, so the code word lengths are not fixed. But in a fixed length code, here you will see A is having 3-bit, B is having 3-bit, C is having 3-bit, D is having 3-bit, E is having 3-bit, and F is having 3-bit. So all the code words are fixed. Now, let us try to find out what is the difference between a fixed length code and a variable length code. Now, let us look at this example. Suppose we have a 100,000 character file. we have a character file like this: A, B, C, A, B, B, C, B, D, E, F, F, A, B, C, D, so on and so forth. And the number of characters in this file is 100,000. Okay. Now, there are only 6 symbols in the universe or in the alphabet. Okay. Now, with this information, let us look at this table. So this table says that this is the symbol, and in the file, how many times it is occurring. Okay. If it is a 100,000 file, suppose I have a character file like this. Yes. In this character file, what is the frequency of A? What is the frequency of B? What is the frequency of D? Frequency is the number of times a symbol occurs. Okay, so for this given example, A is occurring 1 time, 2 times. B is occurring 2 times. C is occurring only 1 time. And D is occurring only 1 time. So this is the frequency of this particular string. Okay, suppose now we have a large file which is 100,000 characters long. Okay, in that the frequency of A is given 45,000. The frequency of B is given 13,000. C is given as 12,000. D is given as 9,000. D is given as 16,000. E is given as 9,000. And F is given as 5,000. So, in this large file, A occurs 45,000 times, B occurs 13,000 times, C occurs 12,000 times, D occurs 16,000 times, E occurs 4,000 times, and F occurs 5,000 times. Okay. So this is the meaning of this first line, which is the frequency. So how many times each symbol is occurring in 1,000? Okay. So this is 45,000, 13,000, 12,000, 16,000, 9,000 times, and F is occurring 5,000 times. Okay. Now there are 6 symbols. How many bits are required? Minimum. 2 to the power 3 is equal to 8. So minimum if I take 3 symbols, because 2 to the power 2 is equal to 4. 4 is less than 6. So this cannot be the value of B. So the value of B has to be greater than the number of symbols. At least equal to or greater than. So this will satisfy. So at least 3 symbols are required in the
3 bits.
Sorry. These 3 bits are required in the fixed length code. If I am taking a fixed length code, at least 3 bits will be required. If 3-bit code words you are taking, what are the different code words that can be formed? 000, 001, 010, 011, 100, then it will be 101. These are the 6 code words that can be used. This is the value of 0, 1, 2, 3, 4, and 5. Okay. So these 6 different values can now be used as the fixed length code words. So that is what they have used. Okay. So yes, if another symbol was there, that would have been given the value of 6. Then there would be 7, there would be 8, there would be 9, so on and so forth. Okay. Yes. Now, we were studying the difference between fixed length codes and variable length codes. We will come how we can find a variable length code. Fixed length code, yes, you can give directly. A will be given 0, B will be given 1, C will be given. Give distinct code words to each symbol. That is fixed length coding. Okay. Now, if I use the fixed length code, okay, A is occurring how many times? 45,000 times. Okay. For one A, how many bits are required? 3 bits. So for 45,000 A's, it will be 45,000 into 3 bits. For B, it will be 13,000 into 3 bits. For C, it will be 12,000 into 3 bits. For D, it will be 16,000 into 3 bits. For E, it will be 9,000 into 3 bits. For F, it will be 5,000 into 3 bits. This is the total number of bits required to encode the file. Now calculate this total and tell me how much is the number of bits, total number of bits. Yes, what is the total value? कितना है वैल्यू? अरे इसको टोटल नहीं कर पा रहे हो?
Sir, 300,000.
300,000. Yes, it is correct. So total 300,000 bits will be required to represent a file of 100,000 characters using the fixed length code. Okay. Now let us go to the same example and now calculate the number of bits that are required using a variable length code. Now A is occurring 45,000 times into only 1 bit is required. B is occurring 13,000 times. 3 bits are required. C is occurring 12,000 times. Okay. How many bits are required? 3 bits are required. D is occurring 16,000 times. How many bits? 3 bits are required. E is occurring 9,000 times. 4 bits are required. Okay. F is occurring 5,000 times and 4 bits are required. Tell me the total number of bits if a variable length code is used.
Sir, 224,000.
2,24,000. Yes. Fixed length code में कितना यूज हो रहा है? Variable length code में कितना यूज हो रहा है? Are we using lesser number of bits using the variable length code?
Yes, sir.
What is the compression ratio? How much compression can we achieve if we are using a variable length code? Initial minus final by initial. Okay. 3 lakh minus 2,24,000 by 3 lakh will give you the compression ratio. So that is not my point. My point is the difference between fixed length code and variable length code. Okay. When a fixed length code will require 300,000 bits, that means more number of space will be required. Same variable length code, it can do it with 2,24,000 bits so that the space required is now reduced. Okay. The reduction in the total number of bits required to encode a file is known as data compression. What is the meaning? The reduction in the total number of bits. How we compress the data? Same data, if you used fixed length code, 300,000. Okay. Same data using variable length code, 2,24,000. Now we have compressed the data. Yes? So, yes. Now, we move to the topic which is Huffman codes. Yes. What is Huffman code? Huffman codes are a greedy approach or is a greedy approach that assigns variable length codes. We just now saw what is a variable length code. How can you achieve a variable length code? Huffman coding is the algorithm which allows us to get a variable length code. Okay. So depending on the type of data that is to be compressed, there is a best case and there is a worst case. So in the best case, Huffman code can compress up to 90%. Okay. And if 1,100,000 bits were required, then Huffman code can do it only with 10,000 codes. There are some cases where the Huffman code can achieve only 20% compression. Okay. So basically this Huffman coding scheme, it achieves a compression ratio of 20 to 90%. Okay. Depending on the characteristic of the data that is being compressed. Okay. So depending on the data to be compressed, Huffman codes will perform. Now we consider the data to be a sequence of characters. Okay. Only for the purpose of understanding it. In real life, Huffman codes can compress everything. Images, text, everything can be compressed by Huffman codes. Okay. Huffman's greedy code uses a table of how often each character occurs. So this is the table that Huffman code will use. It will use how many times each character occurs. That information has to be given to the Huffman codes. Without this frequency information, required for Huffman code, okay, without the information of the frequency, Huffman code cannot produce a variable length code. Okay. Yes. Now let us take the same example. Let us go to the algorithm, then we'll come back to the example. Okay. The algorithm is saying Huffman code will take symbols and their frequency. Okay, that is the input to this algorithm. N is equal to the number of symbols. Okay. Now we are going to put all the symbols into a mean priority queue. Okay, based on their frequencies. Symbol and its frequency. Based on the frequency, now we will put every symbol into the mean priority queue. Okay. Now, for 1 to n minus 1, inside the loop, what we will do, we will extract the two minimum most nodes, okay, whose frequency is least. Suppose A is having frequency 2 times, B is having frequency 3 times, C is having frequency 4 times. Okay. Then inside this loop, a new node will be created. Okay. And the two least most children or the two minimum most children in the queue, that are A and B, because their frequency is lesser than C. Okay. These two will be extracted. Now A will become the left child of the new node Z, and B will become the right child of the new, sorry, A is 2, B is 3. B will become the right child of the new node Z, and the frequency of the new node Z will now become the frequency of its left child plus the frequency of its right child. So this is 2 plus 3. The frequency of the new node will now become 5. Okay. So again, this process will be repeated, and finally we will just return the root of the tree. Okay. We will go on doing this process. This is the basic idea here. To extract the two most least frequency children and add it to a new node. And the frequency of the new node is now equal to the frequency of its left child plus the frequency of its right child. Okay. Yes, I know this algorithm is confusing. If you see the example, then the things will be clear. Yes, let me just take the example. It is A5, E9, C12, B13, D16, E45. What are these? These are the symbols and their frequencies. Okay. So yes, now I have taken the symbols and their frequencies. Now we have also arranged them according to their increasing order of frequencies. Okay. Why? Because we are placing it in a mean priority queue. Okay. Now let us follow the steps. In the first step, it is saying that the two least most children, F is having frequency 5000, E is having frequency 9000. So among all the symbols, these two are the symbols whose frequency is least. Okay. Take those two symbols.
Excuse me, sir.
Yes, yes.
Sir, D is 306.
D16. D16, na? Yes. D16. Okay. Now, F and E, they are having the least value. Okay. So, they will be created into a new node. The new node will now have a frequency 5 plus 9, which is 14. Its left child will become F with frequency 5000. Its right child will become E with frequency 9000. Okay. Now again, insert this new node into the mean priority queue. So if I insert it, now the order will change. Okay. Earlier there was F, E, C, B, D, E. Okay. Now it will become C12 because that is the least one. Then it is B13. Then the new node 14, whose left child is F, whose right child is E. Okay. Then there is D16 and there is E45. Sorry, A45. Okay. This is A. This is my new queue. Okay, this is the step 1. This is the iteration 2. Okay, in the iteration 2, 3, again 2 least frequency nodes will be added to form a new node. So if these two are added, the new node will be 25. Its left child will be C12. Its right child will be B13. Again, insert it into the queue. If I insert it into the queue, now the queue in step 3, it will look something like this. It will be 14. Its left child is F5. Right child is E9. Then the next one will be D16. Okay. Then the next one will be 25. 25's left child is C12. Its right child is B13. And there will be A45. This is the third step. This is the first step. Just a second. This is the step 1. This is total. Step 2. And in the step 3, this is the value of the queue. Okay. Now in the step 4, again these two will be combined. If these two are combined, now the new node will be 30. Okay. Since 30 is greater than 25, let us maintain the order. 25, C12, B13. Next one will be 14 plus 16, 30. 30's left child will be 14. 30's right child will be D16. The left child of 14 is again F5, E9. Okay, and we have A45. This is the step 4, iteration 4. Let us go to the iteration 5. Now in the iteration 5, this is the tree that we have, or this is the queue that we have in fact. Now 25 and 30 will be combined. So it becomes A45. Okay. And the second node will be 25 plus 30, which is 55. 55's left child will be 25. 55's right child will be 30. Okay. Now again, 25's left child is C12. 25's right child is B13. Again, 30 has a left child 14. 30 has a right child D16. Okay. 14 again has left child F5, E9. Okay. Now in the sixth iteration, this is the fifth step. In the sixth iteration, these two will be combined. 45 plus 55 is equal to 100. Okay. 100's left child is A. 100's right child is 55. Okay. 55 has two children, 25, 30. 25 has two children. One is C12, B13. 30 has two children, 14 and D16. Yes, 14 again has two children. One is F5, E9. This ends the algorithm. And this is the final tree that we will get. Yes, is it clear? Anyone who could not understand? Start from this step. Start from this step. Come up with the tree. Yes, jaldi karo. Start from this step and come up with the tree.
Sir, what is that 0, 1, 0 and 1, that branches?
I will tell you. Once you come up with the tree, then I will tell you.
Okay, sir.
Try to complete the tree. एक बार करो तो दिमाग में रह जाएगा. Just from the frequency and the symbols, try to build a Huffman tree. Yes, tree बन गया. Yes, anyone has completed the tree. I'm just going through the process again, so those who did not understand can look at the slides. Okay, so the Huffman code algorithm will take symbols and their frequencies. Okay, in thousand, in hundreds, we don't matter. Okay, now we have written the symbols and their frequencies in the increasing order of their frequencies. Okay, the algorithm says the first step is you add the least frequency nodes. If I add F5 and E9, a new node will be created which is 14. It will have two children, F5 and E9. So now a new node is created, 14, whose left child is F5 and right child is E9. Okay, and again we insert it into the queue. If you insert it into the queue, it will be in the third place because C12 is the least frequency, B13 is the next frequency, then the place of 14 will come. Okay, then there is D16 and A45 as usual. In the next step, again these two least frequency nodes will be combined to become a new node, 25. Okay, this 25 will be placed in the third place because now after combining, this will become 25. So 14 will come first, then D16, then 25. Okay, and as usual, A45. Okay, now we combine this 14 and 16. If you combine 14 and 16, the total value will be 30. So first 25, then this new node 30 will come. Okay. After combining, A45 is there as usual. Okay. Now, the least two nodes are 25 and 30. Okay. So 25 and 30 will be combined to become 55. So one node is 55, which is the second node because A's frequency is 45, lesser than 55. Okay. So now these two will be combined to form the final node whose value is now 100. 45 plus 55 is equal to 100. Okay. For 100, now the left child will be A and the right child will be 55. Then the subtree of 55 will be there as it is. Okay. If you look at the point here now, this is the final tree that we will get. Okay. In this final tree, now there is an interesting point to look. The last step, what you do is for all left branches, write 0. For all right branches, you write 1. So you see, in the left branch here, I have written 0. In the right branch, I have written 1. Left branch again 0, right branch 1, left 0, right 1, left 0, right 1, left 0 and right 1. Okay. So if we write the value of 0 and 1 in each of the branches, this will give us the variable length code. Now, for length of A, I will start, for the code word of A, which is a variable length code word, I will start at the root. And by taking a 0, I can reach A. So the code word of A is 0. By taking 1, 0, 0, I can reach C. So the code word of C is 1, 0, 0. From root, I can take 1, 0, 1 and I can reach B. I can take 1, 1, 0, 0 and that will be the value of F. Okay. I can take 1, 1, 0, 1. That will be the value of E. Okay. Similarly, the value of D is 1, 1, 1. Okay. So these are the variable codes that we require. If you go back to the example here, these are the exact values that we have got. Okay. A is 0. A is 0. B is 101. B is 101. C is 100. D similarly is 111. E is 1101. 1101. F is 1100. F is 1100. So this third line has been generated by Hoffman codes. Okay. So yes, by using Hoffman codes, you can always come up with the variable length code words if the frequency of each symbol is given to you. Yes. Is it clear or anyone has doubts?
So the smallest value will be always in the left node.
Yes. The smallest, no. The highest frequency symbol will always get the smallest code word.
No, sir. Can you show the graph? Tree structure.
Yes, it will be 100. 100's left child is, I am going to that tree. Yes.
Here the left node are always small.
Yes, the left will be always small. And if you see, the highest frequency symbol is getting the smallest keyword. And जिसका frequency सबसे कम है, that is present at the lowest level and they are getting the largest number of code words. Okay. F का frequency सबसे कम है, इसलिए it has a 4-bit code word, which is 1, 1, 0, 0. But A is having the largest frequency, that is why its code word is a single bit. Okay. Yes. Is it clear or any doubts?
Yes, sir.
Is it clear how we are doing Huffman codes? What is the advantage of Huffman codes? What is fixed length code? What is variable length code? What is encoding? What is data compression? All those concepts are clear. Okay.
Yes, sir.
Yes, I've shared the link for today's quiz. You can go to the quiz and tell me if it is accessible to you or not.
Yes, sir. It's accessible.
Karo. Yes, prefix code is that code in which no other code can be the prefix of any other code. Okay.
सर प्रीफिक्स कोड का क्या बोल रहे
Prefix codes are those codes in which no code word can be the prefix of another code word. Yes, everyone has completed the quiz. Okay, we'll meet in the next class where we'll start a new topic. Okay, until then, if you have any doubts, then let me know. Thank you all.
Good afternoon, friends.
This call is now being recorded.
Good afternoon, friends. Am I audible?
Yes, sir.
So, yesterday we discussed the time value of money. We discussed how the money has value over different time periods, and money has a value over different time periods because money has a purchasing power, and also money has the owning power. Because of the inflation, purchasing power of money changes over different time periods. If there is rise in prices, purchasing power of money decreases or the value of money decreases. If there is fall in price level or deflation in the economy, the purchasing power of money rises. Money has the owning power depending on what is the rate of interest prevailing in an economy. Higher the rate of interest, more is the owning power of money. Lower the rate of interest, lower will be the owning power of money. So based on this, already we discussed how much money one can get after certain period of time with the given rate of interest, or what is the future value of money given the rate of interest and the number of periods for which it will be held. Now we will continue with this analysis further. Now, yesterday we discussed how we can find out the future value of money. They are here in this formula. F refers to the future value of money, P refers to the present value of money, R refers to the rate of interest, and N is the time period. Already discussed, given the present value, that means if you deposit certain amount of money today with the given rate of interest and time period, how much will you receive after a certain period of time. Considering the future value of money, if one has to get a certain amount of money after some period of time, how much he will save right now? How much he will deposit in the bank right now so that he will get a certain amount of money after certain period of time with the given rate of interest that we have discussed. Now, we will go to that, and I will take a simple example on that again, and basing on the example, we will go ahead. Let us assume a woman borrowed. The question is like this. A woman borrowed let us say rupees 2000 and agreed to repay it at the end of 3 years, together with 10% simple interest per year. How much she will pay after 3 years? What will be your answer? What will be the answer here? Subham Kumar is saying 2,600. Any other answer? Any other answer from anybody else? So how will go? Your future value here is the present value plus the interest. Simply speaking or solving it arithmetically. So principal amount we are getting 2000, and what is the interest we will get? That is 2000 multiplied by rate of interest is 10%. 10% will take 0.1. What is the number of years? 3. So that we are getting 2000 plus this is 2000 multiplied by 0.1, 200 multiplied by 6, 600. That we are getting 2600. Now, the same question, if we take it that with 10% compound interest, 10% compound interest, how much she will pay after 3 years? If we take the compound interest, you can go stepwise or you can go directly putting the formula. Formula is already given. The future value will be here 20,000 into 1 plus what is the value of R? 0.1 to the power n is equal to 3. That is equal to 2000 multiplied by 1.1 to the power 3. That is 2000 multiplied by what is the value 1.1 to the power 3? Please. This is 1.1 to the power 3. So we are getting 1.331. So that will be multiplied by 2000. We are getting 2662. Clear? Now we can also, same question, we can revise it. A woman borrowed a certain amount of money. How much she is borrowed? Borrowed a certain amount of money and agreed to repay it at the end of 3 years together with 10% compound interest per annum. She repaid rupees 2662. If she repaid 2662, how much she has borrowed? So while coming across this type of questions, so please see what is given and what you have to find out. So woman borrowed a certain amount of money at present. So this is not given. You have to find out the value of P. What is given? Your R is given. Your rate of interest is given 0.1. Time period N is given, that is 3. And future value is given 2662. You have to find out the P. So you can go to the formula. P is equal to future value 2662 divided by 1 plus 0.1 to the power 3. That is 2662 divided by 1.1 to the power 3. That is 2662 divided by 1.1 to the power 3. So you are getting 1.1 to the power 3. You are getting 1.331. And that we are getting 2000. So this much we have discussed. Now I am taking the same question further. You are thinking of buying a plot, paying a price of 70,000 at present. The plot will be of worth 1 lakh rupees after 5 years. Will you purchase it if the rate of interest 5% or rate of interest is 10%? Your consideration is, so you are more, or your consideration, to take it in that way, your consideration will be the cost of the plot. How you will proceed. So I am putting it in a timeline. So you pay 70,000 right now, purchase a plot, and the plot will be worth after 5 years, 1, 2, 3, 4, and 5. The plot can be sold at 1 lakh. And you have been given the rate of interest is 5%. Assume first. Now, your consideration is the cost of the plot. So you cannot compare the 70,000 with the 1 lakh. The 70,000 and this 1 lakh are not same. What you will do? While you compare the value at one time point, at one point of time. And here you have been giving your consideration is the cost. Cost means how much you are paying right now. So you will compare how much you will pay right now. Now, how much you will be or you would to pay if you will receive 1 lakh after 5 years. Or what is the present value of the 1 lakh before 5 years or at present? 1 lakh that you will receive after 5 years. How much its value today? So this is the cost. And if you give this 1 lakh you will receive, how much you have to pay at present? This is you pay and how much you have to pay. In this case, how much you have to pay? Your future value is given. You have to find out the present value. And how will find out the present value? I'm directly going to that. P is equal to 1 lakh divided by the rate of interest is 5%. So 1 plus 0.5 to the power 5. So please calculate and tell me what will be its value. Anybody please calculate and tell me what will be its value. (1.05 to the power 5). So that we are getting 1 lakh divided by 1.27628. That is equal to 1 lakh. Directly I am going to that. 1 lakh divided by 1.27628. So we are getting this is 78,352.71. This is approximately. So you paid 70,000 to purchase that. But if it will be sold at 1 lakh after 5 years at a rate of interest 5%, how much you have to pay? How much you have to pay right now? You have to pay 78,652, or I am taking rounding it, 78,353. Now you actually paid 7,000. Now to get 1 lakh, you have to pay 78,352. What will be your decision then? Abhyasa? Whether you will purchase this land or you will forgo purchasing this land. Abhyasa Panda. Am I audible or not?
Yes, sir.
Okay. So give your decision. You pay right now 70,000. Now if you have to get 1 lakh with the rate of interest 5% per annum, you have to pay 78,000. You have to pay 78,000, but you are paying 70,000. What will you do?
So we will buy it at this moment.
Arpita, you will buy the?
Sir, we will buy the land.
You will buy the land. So
Yes,
what benefit you will get?
Sir, we are paying less than the amount which we found out.
Okay. So to get 1 lakh rupees, you have to pay 78,353, but you are paying 70,000. So since you are paying less to the extent of 8,353, your decision goes in favor of purchasing the land. Now, if you pay the 10% rate of interest instead of 5%, if you pay 10%, then calculate and tell me what you will do. Calculate and tell me if the rate of interest is 10% per annum. So tell me, what is the value? So my calculation is going with 61,916 approximately. So what you will do? So first, whether my calculation is correct or not. Second, what is your decision? So first tell me whether my calculation is correct or not. Sachin, are you present? Okay, Sachin is not there today. Urus? Urus Salam? Are you getting my voice? Sambit Mahapatra. Sambit Mahapatra. So are you getting my voice? Okay, Arpita, please tell me whether my calculation is correct or not. If it is correct, then what is the implications of this? Arpita, am I audible? So please respond. If I'm not audible, then I will check. Please let me know. Hello, Arpita? Abhishek Puri, am I audible? Abhishek Puri, am I audible to you? Hello?
Excuse me, sir.
Please, Abhilasha.
Sir, can you explain how we are calculating that present value?
So present value formula is given. So we take this formula. Yesterday we discussed that. This is the formula. How to find out the future value? Given the compound rate of interest, how we calculate the future value? Future value we are calculating using the formula F is equal to P whole into 1 plus R to the power N. So is there any doubt on this? Please tell Abhilasa. If of the doubt, then I will try to clear it.
Sir,
Again. Please, Nisha.
so I have a doubt that when we are finding a 10% rate of interest,
Hmm.
then we are watching for profit of 10% at future.
No, okay. So here, okay, Nisha, please concentrate on the last part of the question. Your consideration is the cost of the plot. Your consideration is not the benefit you are receiving. Your decision is based on how much you have to pay. Your decision is not rest or is not resting with how much you will get after future time. So you can take the decision basing on what you are saying. If I will deposit 7,000 right now, how much I will get after 5 years? If I will get more after 5 years, then I will purchase the land. If I will not get more after 5 years, then I will not purchase. Simple decision. But here decision you are thinking basing on how much you will pay. What is the cost? If you pay less right now, then you will purchase. If you pay more, you will not purchase. Nisha, any doubt?
No, sir.
Okay. So what you are saying, had it been the case, your consideration is based on how much you will receive. Then what you are saying, we will go, we will find out what is the future value of 70,000. Then we will compare 1 lakh with the future value of 70,000. If the future value of 70,000 will be greater than 1 lakh, then we will purchase. If the future value of 1 lakh or say 7,000 is less than 1 lakh, then you will not purchase. You think, again, future is uncertain. So you are thinking that I will definitely get 1 lakh after 5 years. How much I will pay right now? Okay. Now, if we go with 10% rate of interest, what we are finding, the present value of 1 lakh for a period of 5 years and with the rate of interest 5% per annum compounded annually is 69,960. Since you are paying more than the present value here, 61,916. So if the rate of interest is 10% per annum, then you will not purchase the land. Any question on this? If there is no question, then we'll move to another concept. Here we are discussing finding the present value or future value of a constant sum. Future value or present value of a constant sum. Now, if we have to pay certain amount at equal intervals of time, then what will be the case? Now, the question is, now I'm putting a simple question. The question is like that. After 5 years, you will receive 10,000 rupees. You can pay, let us say, 9,000. You can pay a lump sum amount of rupees 9,000 at present or rupees 1,800 per annum. Which mode you will adopt if the rate of interest is 10% per annum or 10%, I can say, compounded annually. %, compounded annually. Now, how we proceed? Now, if I put it in a timeline, this is my timeline. I am to receive 10,000 rupees after 5 years. This is your 1, 2, 3, 4, and this is 5. And I will receive. So yesterday I told you in the timeline, the cash inflow will be indicated at the bottom arrow, top arrow. Cash outflow, bottom arrow. So when I will receive 10,000 after 5 years, so here I will receive 10,000. So option is, I will pay 9,000 at present. So this is the present value 0. I will pay 9,000 here. Or I will pay 1,800 per annum. So here I will pay 1,800, here 1,800, here 1,800, here 1,800. So here also over 5 years we are paying 9,000. Which move will be best suitable to you? What we'll do here? We cannot compare this 9,000 you are paying right now with the 1,800 you are paying over a period of 5 years. Now, to solve this, I am taking this in this way. This is 0, 1, 2, 3, 4, 5. So you are paying 9,000 here. You are paying 1,800 here. Rate of interest is 10% or 0.1. So you are paying 1,800 here. You are paying 1,800 here. You are paying 1,800 here. You are paying 1,800. Now, what is the present value of all the 1,800 you are paying? What is the present value of this 1,800? 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 And what is the present value of this 1,800? So just check it. So this, what is the present value of this 1,800? So you are paying 1,800 after 1 year. So what is the present value of 1,800 for 1 year? So we say present value is equal to future value divided by 1 plus I to the power n. This is our formula. So I am putting it here. Present value is equal to future value divided by 1 plus I to the power n. Now if I put it in that way, how much I will future value is equal to 1,800 divided by 1.1 to the power 1. So what is the value? 1800 divided by 1.1. Please help me so that we can be able to discuss more quickly. 1000 divided by 1.1. So approximately we are getting this 1636. 1636. For the second year, what you are paying 1800, if you have to receive 1800 after 2 years, how much you have to pay right now? This will be equivalent to 1.1 to the power 2. So this is 1.21 or 1800 divided by 1.21. So this we are getting approximately 1488. So this is 1800 divided by 1.1 to the power 2. For the third year, how much? Similarly, you compute 1.1 to the power 3, 1.331. So this is 1800 divided by 1.331. So it is coming 1352. So this is 1800 divided by 1.1 to the power 3. Again, for the fourth year, you are giving 1.1 to the power 4. This is 1.4641. So 1800 divided by 1.4, okay, 1.1 to the power 4, 4641. 1800 divided by 1.4641. So we are getting 1229. So this is 1800 divided by 1.1 to the power 4. And last one will be 1800 or 1.1 to the power 5, 1.610, 1800 divided by 1.6105. So we are getting 1118. So this is the present value of the future payments we are giving. So how much we have to pay right now? Instead of paying 1800 over a period of 5 years, if we have been asked to pay the money at present, how much we will pay? This is 1636 plus 1448 plus 1352 plus 1229 plus 1118. How much you have to pay? This is 6783. So let me take it again. 1636, 1488, 1352, 1229, then 1118. 68. Okay, so this will be 6823. Now then tell me whether you would like to pay 9,000 right now or 1,800 per month over a period of 5 years to get these 10,000 rupees after 5 years. Tell me.
1800 per year.
Why 1,800? Because we have to pay less. If we have to pay 1,800 per year over a period of 5 years in comparison to 9,000 lump sum, a fixed amount. In this example Clear or any doubt? Now, this payment of equal amount of money at equal interval. So please, sorry, please concentrate on this equal amount of money at equal interval is known as the annuity, or we can say payment or receipt of equal amount of money at equal interval of time is known as the annuity. And this annuity is of two types. One, annuity, or we say immediate ordinary annuity, ordinary or deferred, ordinary annuity or deferred annuity. I am simply taking the ordinary, or we can say tell it DFERRED, deferred annuity, or second is what we say annuity due. Two types of annuities are there. One is ordinary or deferred annuity. Second is annuity due. When we say ordinary annuity, so in this example, when this 1800 is given, beginning of the time period or the end of the time period? When this 1800 is paid, after the end of the year or before the end of the year or before the beginning of the year? Please respond. This is the 0 is the beginning of the year. 1 is the end of the year 1 and start of the year 2. So when you are paying this 800 at the end of the year, when annuity is paid at the end of each period, then we say this is the ordinary annuity. So annuity paid at the end of the period, But when annuity is paid in the beginning of the period, when annuity is paid at this point, 0, then we say this is your annuity due. Now, instead of the payment made, if the payment made in this way, 1800, 1800, 1800, 1800, and 1800, then this is the case of annuity due. Annuity due. But when payment is made at the end of each year, that we say this is the ordinary or deferred annuity. Is this concept clear or any doubt? And how we will find out the value of the present or future value of an annuity, present value of the annuity, installments for future, annual installment for present, that we'll discuss in the next class. Now this is the time for quiz, and you have been, please note the link. So in the chat box, link is given. Open the Google form. 4 questions are there. You have been given sufficient time. 15 minutes is given. So calculate and submit the Google form. 15 minutes time is given. So by that time, I am taking your attendance. So please respond to the attendance. Somashri Biswal,
Present, sir.
Anushka Das,
Present, sir.
Dipasha,
Present, sir.
Ayush Prasad, G. Anish Kumar,
Present, sir.
Shubham Das,
Present, sir.
Soumya Danpat,
Present, sir.
Abhijit Anand,
Present, sir.
Abhishek Puri,
Present, sir.
Roshan Panigrahi, Phalguni Mishra,
Present, sir.
Rajat Kumar Naik,
Present, sir.
Angana Ghosh,
Present, sir.
Aniket Mahanti, Roshan Panigrahi present, Aniket Mahanti, Anisha Patnaik,
Present, sir.
Chanchali Satpati,
Present, sir.
Shatabdi Dhara,
Present, sir.
Siddhan Swarup Malik,
Present, sir.
Arnab Sarkar,
Present, sir.
Arnab Datta,
Present, sir.
Arpita Nandita,
Present, sir.
Arpan Kumar Bhartia,
Present, sir.
Diya Kiran,
Present, sir.
Gitika,
Present, sir.
Harshit Raj, okay, Harshit Raj present, Manas Ranjan Biswal, Kamlesh Sathwa,
Present, sir.
Kasmik Mahanti,
Yes, sir.
Shashank Chaudhary,
Present, sir.
Mehul Puri,
Present, sir.
Sanjog Das, Abhilasha Panda,
Present, sir.
Sambit Mahapatra,
Present, sir.
Ankit Raj,
Present, sir.
Nishchay Singh,
Present, sir.
Priti Kara,
Present, sir.
Rajesh Kumar Barik,
Present, sir.
Raktim Sildas, Raunak Raj,
Present, sir.
Pushpendra Kumar,
Present, sir.
Aditya Narayan Roy,
Present, sir.
Ritik Patnaik,
Present, sir.
Roshan Mishra, Shahnawaz Alam,
Present, sir.
Animesh Sahu,
Present, sir.
Shubham Kumar, present, Vaibhav, सचिन कुमार पांडे, शुभजीत दे,
Present, sir.
सुप्रीति सिन्हा,
Present, sir.
सूरज कुमार महातो,
Present, sir.
शुभम पटनायक,
Yes, sir.
श्वेता दास,
Present, sir.
उदित नारायण ओझा,
Present, sir.
उरुस आलम, विवेक शर्मा,
Present, sir.
अंजलि सिंह, सत्यव्रत बेहरा,
Present, sir.
आदित्य नारायण मिश्र, रोहन हरिचंदन,
Present, sir.
छतवंत कुमार शाह, अनन्या अनंदिता,
Present, sir.
अनिमेश अभिनंदन,
Present, sir.
अंशुमान पटनायक,
Present, sir.
श्रुति कृति दास,
Present, sir.
आयुष पटनायक, निखिलेश बेहरा, anybody left?
Sir, me, Tanisha Rao.
Tanisha Raut, okay. Your name has not been inserted here. Okay.
Yes.
अनिकेत महांती, present. You have now 7 minutes left. Please complete the quiz and submit. Manas Biswal, are you present? Manas Biswal. Manas Biswal. Vaibhav, are you present, Vaibhav? Uru Salam, are you present? 3 minutes left. Twenty-three, 24 responses received. Please submit quickly. So thank you all.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye, sir.
ठीक है, ठीक है.
हो गया ना, बस सर चले गए, रहने दो अब.